Compliant-based couplings use material deformations to connect physical objects. In such couplings, important design considerations include the ease of insertion and removal, the grip strength of how the inserted object is locked in place, as well as the structural soundness of the deforming bodies. Given an arbitrary compliant structure and a rigid object, we present a method for designing the compliant coupling behavior between them. In this case, the door knocker can be inserted with a physically reasonable force and can move freely once inserted into the lion's mouth. We use deformation profiles to capture the coupling behavior. A distinct steady-state minimum in the elastic energy attained after passing through a maximum energy state signals the presence of a valid coupling. In such cases, no external force is necessary to keep the objects coupled. A non-zero steady-state energy signals a grip force locking the objects together, while a zero steady-state energy corresponds to a loose couple. If a dip in the elastic energy is not present, this would mean the two objects would simply disengage after the externally applied forces are removed. Our algorithm takes as input a compliant structure and a rigid inserted object. We start by placing a set of deformation handles using our displacement-based clustering method. Simulating the insertion process through a progression of states, we obtain the elastic energy and force profiles. These deformation profiles allow us to capture a set of critical states that characterize the coupling between the objects. By repeatedly performing insertion simulations within an optimization loop, we modify the rest shape to achieve the desired compliant behavior. The 3D printed compliant alligator attachment allows the insertion of the marker without breaking, firmly holds the marker in place, and allows it to be removed with a reasonable force. Here are our results. Our optimized connector enables an easy insertion and removal of a paddle while it stays tightly attached to the stand. We designed an assistive door handle for people who have trouble gripping doorknobs. Our attachment allows the phone to be connected to the charging block. Both sides of the structure are optimized for firm grips while allowing easy insertion and removal. Here, we optimize the mechanical claw to grab onto the bunny model. We also designed the alligator shape to be attached to another bunny model. In this example, we design a set of building blocks with fine-tuned physical grips. Our simulations demonstrate how the deformation profiles capture different coupling behaviors. The building blocks with a loose grip can be used to create chain-like structures. Or stiff structures can be obtained by assembling blocks with tight grips. The location of motion transfer can be controlled by placing a less tight piece in an array of tighter building blocks. When we pull the structure apart, it separates at a tight grip block. As seen, our formulation can decouple grip strength from insertion and removal forces, thereby creating behaviors that are not easily attained with manual trial and error. Thank you.